A2 further maths, reciprocal and inverse hyperbolic functions. Right, so what I'd like you to do is just have a go at sketching the curve y equals sine x. Try to do that without your notes, but if you need to grab your notes, feel free to do that. Okay, right, so hopefully you did it without your notes. If you didn't, you need to make sure that you know these graphs off by heart ready for that exam. So the sine function looks like that. Now what I'd like you to do, please, is just in your notebooks, make sure you've got the sine function written down, quick sketch, and state for me the range and domain of that function. Okay, so hopefully you notice that the domain, although it does look like it's sort of tailing off, it doesn't, it just keeps going off in both directions. So your domain works for any x values you like. And the range, what numbers you can get out, is also any values you like. You can put an x value in, you can get any y value out. So the domain is all real values and the range is also all real values as well. Notice now you can sketch for me the inverse graph of y equals sine x. So pause there, have a go at sketching the inverse graph of y equals sine x. Okay, this should be looking at plotting the line y equals x. So if you plot the line y equals x, once you've done that, then you can reflect in that line and therefore you will get your inverse graph to y equals sine x. Okay, the way you can write that is sine to the minus 1, the sort of thing you've seen before with sine, cos and tan to the minus 1, or you can also write it as arsech as well. Okay, with an AR in the front. So arsech x is an alternative way of writing the inverse function of sine. It's different to 1 over. We'll come back to that later on, but just be aware, sine to the minus 1 or arsech is the only way to write it. Notice that the domain is any real values and the range is also any real values. But you knew that because it was the opposite way round to the previous answer. Okay, so same again, grab your notebooks, have a go at quick sketching the cosh graph. If you don't remember what the cosh graph looks like, feel free to flick back in your notes, but if you can remember it out your notes, even better. So just pause there until you've sketched it. Okay, so hopefully you remember that the cosh graph looks very similar to a hyperbolic, to the x squared graph, to the parabola, except it doesn't seem to cross at 0, 0 because it doesn't, and also it's got a bit more flat bottom than a parabola. So what do we have here? We have the graph of cosh x. What I'd like you to do is work out the range and domain. I've just spoilt the domain for you, put it on early. Yes, the domain is any values you like, but what about the range? Okay, so the range looks like you can get any value. You could definitely get 2 out, 3, 4, and so on. You can get 1 out as well, but you can't get anything below 1. So the range is anything above or equal to 1. Right, so we know what the range and domain are. What I'd like you to do is tell me why it doesn't have an inverse. So why doesn't that graph have an inverse? So have a think about it. And you'll be correct in saying it doesn't have an inverse because there is not a one-to-one function. It's not a one-to-one function because, for example, if you want to get the number 2 out on the range, you could put in this value here in the domain and get it, or you could put this value in to the domain and get it. So there's multiple ways of getting the number 2, and because of that, because there's not one way of putting it in, it is not one-to-one. So how can we draw the inverse graph of cosh x, or how can we find the inverse of cosh x? Well, we have to restrict the domain. And we can do that the same way as we do it with the x squared curve. We just ignore the negative values and we restrict ourselves to all the positive values and 0. So there we go. Now it's down to a one-to-one function. One value in, one value out. 2 goes in, this number comes out just here, below 4. And so on. Okay, now what I'd like to do is have a go at sketching the inverse then. So pause, have a quick go. Okay, so let's see how you got on. Same idea as before. Because I've got the graph, I can sketch the line y equals x. So I'm going to sketch that graph line y equals x, and I can reflect some of these key points. So I know it crosses there at 1, 0, 1, so it's going to cross at 1, 0, and it's going to look similar to that. It's going to look similar to a root graph because that was similar to a parabola graph. So there's no surprises when you get to see it. So there you go. Sketch that down in your notebook. What's the range? What's the domain of that function? We can write it as cosh to the minus 1. We can write it as arcosh. And I'll flick between them, both saying both of those words. So it could be the arcosh. And its range and domain, well, its domain, as you can see, is anything greater than or equal to 1. And its range will be any values greater than 0. And if you remember, we restricted our domain a minute ago to all positive values. That's why now the range is restricted to all positive values than 0. Before, as you can see from this graph, the range was 1 or higher. That's why the domain becomes 1 or higher for x. So the domain and range swap places when you do the reflection in the line y equals x. Okay, don't pause there if you still need some more time. Right, and back to the same idea. Can you sketch the tanh graph? See how you get on with the tanh graph. So pause until you've had a go yourself. Okay, so well done if you managed to draw a graph like that. And before I give you any hints on that graph, I want you to think about the range and domain. So what values can you put in? What values can you get out? So again, pause if you need a bit of thinking time. Okay, so definitely you can put in any values you like. I know it seems to stop at 3 here, but you can put in 4, 5, 6, you can put in a million, you can put in anything you like. Okay, so the domain, the numbers you can put into this function, are all the real values. Any values you like can go into there. What about the range of solutions you can get out? Well, look, you can get out 0.5, you can get out 0.75, you can get out 0.999, but it doesn't matter how hard you try and how far along you get, you're never going to get 1, you're never going to get minus 1. So the range, and you're never going to get below minus 1 or above 1. So your range of values is anything between 1 and minus 1, not including them, and certainly nothing outside of that range. Does it have an inverse? Yes, it's a one-to-one function. You can put in any value, get one value out. So I would like you to have a go at sketching that inverse function, y equals tanh x. So again, pause. Okay, so let's see how you got on. So there's the tanh graph on squared paper. Hopefully you've drawn y equals x line. And we looked at reflecting it again. So this value here will go over to here. This value here will go down to here. This value that looks like it's crossing at minus 1 will go down here to minus 1, and so on. So I've got a graph that's sort of coming up like that, and then we'll do this. So there we go. That's what my tanh graph looks like. What's the range and domain of that tanh graph? Well, because you know the range and domain of the tanh graph, you should know the range and domain of the inverse tanh graph, excuse me, either tanh to the minus 1 or arctanh. So what values can I put into the arctanh graph? Anything between 1 and minus 1. And what values can you get out? Any values you like. You can only put in those 3 values between 1 and minus 1, but by doing that, you can get out any value you like. So your range is any real values. Okay, so let's look at an exam question on this. Okay, mixing together with the multiple transformations that you did in a previous lesson. So just grabbing that that exam question down in your notebook. I would like to sketch the graph, think about the transformations, and then state the range and domain of that final function. Okay, so you might want to go yourself, so pause if you need to. Right, let's see how far you got on then. So I want to sketch the graph f of x equals arcosech x to start with. So I'm picking that first function out, arcosech. So there we go. I know the graph looks like that. I've remembered what the graph looks like. I've sketched it down. And now I can start thinking about the other transformations. So now I've got that in my head. Let's think about this plus 1. So this plus 1 here is a translation of minus 1 in the x-axis, 0 in the y. So I take the entire graph and I pull it back minus 1. So that's where it's gone to there. So all these points have pulled back one place. Okay, right, what's next then? A negative. So I can think about that. It's a reflection in a line y equals naught. So that graph there will definitely go down to here. There we go. So you can see now it's been translated and reflected. And then what can I do? I think about this 2. Now to me that is a translation of 0, 2 because it's outside the function, so it does what it says. So it's 0, 2. What does that mean then? It means you take the entire graph and we shift it up 2. So that point there from 0 goes up to 2. This point just here will go just below 2 and so on. So there we go. The entire graph has been moved up 2 places. And I'm pretty much there, aren't I? It's almost the same, except for the modulus function, which says that anything negative, so all these values down here that are negative, will be flipped up and made positive. So it's going to have that sort of effect. So there we go. Put the mod sign in, gets us that graph just there. And there we go. I've finished. I've got my final graph, and I can think about what's the domain. So the domain is any values greater than or equal to 0 will definitely work. If I try putting any values I like into that are greater than 0, this function will work beautifully. What about the domain and range? The range, sorry, is a bit misleading because you might look and think this is an asymptote, but it isn't. This function just keeps on going and going and going and going up. It's not an asymptote because it's from the cosh function. So although it looks like it's tailing off, it doesn't. It just keeps. You might have to go really far in the x direction, but you can always go up. So this means that I can get any values I like. Yes, these ones get to 2, but even this value, I just had to go really, really far across to get to it, but I will get to it. So your range is anything greater than 0. Okay? Right, so what I'd like you to do is have a quick go at these exercises. So practicing some of your sketching, practicing some of your transformation techniques. Okay, so we've looked at the graph of shine to the -1 or r shine, and it's very easy to think it's the same as 1 over shine. It's very easy to consider these two and think they are the exactly same equation, but they are not. It's absolutely vital that you understand that shine to the -1 is not the same as 1 over shine. Okay, for the same reason that cos to the -1 is not the same as 1 over cos, which you've done in normal maths. It's very, very different functions. One's a reciprocal, one's an inverse. Okay, so what we do is we give those reciprocal graphs their own names. You would have heard these sorts of names before from normal maths to do with trigonomic functions. So hyperbolic functions is the same sort of idea. So 1 over shine is cosech. Third letter rule still follows here as well. Look, CO divided by shine. So it's cosech. Like cosec with a H. 1 over cos, sec, third letter rule is a C, and you can see that it's sec with a H, so it's sech, sech x. And then finally, 1 over tan was cot, so 1 over tanch is coth. Again, third letter T, tan. So very similar to your normal maths. So these words, although they seem a bit unusual, they are very closely related to trigonomic functions. Right, what we're going to do is investigate the graphs of these 1 over graphs, okay, and see what they look like. So if you still need some time to put in your notebook, pause there. Right, so we want to divide the exponential form. As you know with hyperbolic functions, then that they are written, or they can be written, in exponential form. Now what if that means that you could write the graphs of shine, cosh and tanch in exponential form? It means you can write their reciprocal graphs as well. So let's have a look at this and see what I mean. I know that cosh is 1 over shine. I know that shine x is going to be ex minus e minus x over 2. So 1 over it means you just flip that over. Shine is ex minus e to the minus x over 2. So cosh is going to be, 1 over shine is going to be the opposite way, the reciprocal of it. For the same reasoning, cosh is ex plus e to the minus x over 2. So 1 over it means you flip in that fraction over again. Okay. Tanch was sine over cosh. So cot is just tanh the opposite way around, which is where you're going to get those two parts. So tanh has got the plus on the bottom and the minus on the top, whereas coth is the other way around. You need to make sure you're learning those, but truth is, if you know what sine, cosh and tanh are, and you should do, then it's very easy to get the coth, sech and cosech graphs from them. Okay, pause if you need more time. Right, so let's look at the reciprocal graphs then. So from practicing your reciprocal graphs work that you did recently in the previous lesson, what we can do is we can look at some key points for the sine graph and use that to help us plot the reciprocal graphs. So for example, where the sine graph is equal to 0. So if I know that where the sine graph is equal to 0, the 1 over sine graph is going to be an asymptote just there. And it's going to approach. This one's going to approach from the negative, so it's going to go like that. And this one's going to approach from the positive, because it's just gone past into a positive direction from there. I also know that as this line goes on, this point gets bigger and bigger and bigger. So it just keeps growing. Now that means that this is going to be 1 over a big number, which means it's approaching 0. So I get that sort of graph looking very similar to a 1 over x graph. And there we go. That's the 1 over sine graph or the cosech graph. Okay, what's the range and domain of the cosech graph? Well, you can put in any value except 0. Okay. What about the range of that function? Exactly the same. Any real value can come out except for 0. Okay, so try this one yourself. What's the reciprocal graph of cosh using your skills of spotting or being able to form reciprocal graphs? Okay, so the first thing you should have noticed is that it crosses at 1. Okay, so 1 over 1 is going to be 1, so it's definitely going to cross there. This thing just keeps getting bigger and bigger and bigger, so it's going to start approaching the line. As that gets bigger, 1 over is going to go towards 0, so it's going to go like that. Same on this side. This gets bigger, which means that as that part gets bigger, 1 over it will get close and close to 0. So it's going to come up, it's going to tail off there. That's a stationary point, so therefore it's going to be a new stationary point for the reciprocal graph, and then it will do that. So there we go. That's what the graph of 1 over cosh looks like. So if I know what the graph of 1 over cosh looks like, then I know what the graph of sech looks like. What about its range and domain? Well, certainly its domain, I can put in any values I like. What's the range of values I get out? Interestingly, I can definitely get out 1. I can't get anything higher than it. I can get in all the positive values, but I can't get 0 or below. So my range is anything between 1 and including 1 and 0. So those will be the values I can get out of the sech graph. Okay, so sticking with your notebooks, what about the tanh graph? What does it look like for the tanh graph? So for the tanh graph, I've got an asymptote just there where it crosses. So I know it's going to have an asymptote. This one's a bit more interesting. We've got 2 other asymptotes just here, so I can put my other asymptote line in there and there. Now, because that goes through 1, 1 over 1 will also have an asymptote line. And same with this one, minus 1 will also have an asymptote line. So it's going to be approaching that asymptote line. Because that approach from underneath, 1 over is going to approach from above. Also, this is positive just here, so it's coming down here. So I can see that I've got this sort of curve coming down like that. And the same with this one. That's just above, so this one just below. And it'll be doing that. So there we go. There's my graph, just like that. It's not defined between these 2 values at all, which we'll see now with domain. So 1 over tanh or coth graph, same thing. What's the range and domain? Well, the domain is any values except for 0. The range will be any values above 1 or any values below -1. So any values above 1 and any values below -1 will be the range of values I get out. You have got to learn how to either form those graphs, including the inverse graphs, and you need to make sure you know about the range and domain of each of those graphs. Okay, so I know that cosech is 2 over ex minus e to the minus x. And what I'm going to look at is the inverse of that reciprocal graph. So I'm going to be looking for what's cosech to the minus 1, or arcosech. So if I look at arcosech, then I'll do the same, it's a very similar technique that you did for the inverse graphs in logarithmic form. You're going to use the same sort of technique that you did in your first year. So it's a good idea just to make sure we go back through this relatively slowly to just reinforce what we did in our first year. So if I want to work it out in logarithmic form, the first thing I'm going to do is just rearrange this equation so that I can put the cosech on this side. Because it's the inverse, I'm allowed to do that. If I cosech both sides, it cancels out with this inverse function. So really, cosech y equals x. That's the inverse. Right, I know that cosech is 2 over e to the x minus e to the minus x. So cosech y would be 2 over e to the y minus e to the minus y. Okay? Right, so what I can do with that is I can just multiply the other side by it. So I've got that. And I want to multiply by e to the y. If I multiply by e to the y, let's just look what happens. I get 2e to the y just there. I get x e to the y times by e to the y would get me x e to the y squared. And the e to the y there and this e to the minus y will cancel each other out and make just 1. Okay, which is why we end up with just x, because we've got x times 1. So I got this equation just here. Right, why would I do that? Now I can see I've got e to the y, I've got e to the y squared, and I've got no e to the y's at all. So I can start to consider how to work out what e to the y is in terms of x. Okay, by forming a quadratic equation. Once I've formed my quadratic equation, then I can work out what e to the y is just by using the quadratic equation formula. So e to the y will have the coefficients x, 2, and minus x that I can put into the formula. So there we go. I've put 2 in for my b value. That's it being minus b. I've got b value of 2 still. 4ac, that's where we got x, and x makes x squared. Of course, it's minus and the minus makes a plus. All over 2a, that's why it's 2x. So that is what the equation looks like this there. How can I finish this off then? Well, I can finish it off because I want it in logarithmic form, because it's at the top of the title. I can now just get rid of the e and ln both sides. Okay, just look what I've done here, just to make sure you're happy with this. I've neatened it up, so 4 and 4 is obviously worth the square root of 4 is 2, so I can take a 2 out. I've noticed that 2 is common in all 3 bits, so I can cancel out a 2 and neaten it up slightly. Okay, but that's as neat as it's going to get. So now I can consider taking the e over to make a ln. I also notice here the sorts of values that can actually work. 1 plus x squared. Okay, it's fine. So I'll get y equals ln plus or minus the square root of 1 plus x squared over x. And there's the answer to the logarithmic form for y equals arcosech x. Okay. Now that same technique that you just saw me do there is what you did in your first year when you worked out the sine, cosh, and tanh formulas, the inverse formulas for the logarithmic form. Okay, so what's the domain and range? Well, I know that cosech was like this. Now, because I know what the range and domain of cosech is, I don't need to do any work on working out the range and domain of this function. All I need to do is say, right, if I want the range and domain of the inverse cosech function, the arcosh function, the domain will become the range and the range will become the domain. So for example, in this, the previous range was any values not equal to 0. So the domain will be any values not equal to 0. Okay, what about the other one? Because this one says any values not equal to 0, this one here will be any values not equal to 0. So the range becomes the domain and the domain becomes the range. So what I'd like you to do is just spend a bit of time, have a go at working out the logarithmic form of arsech and arcoth using the same sort of skills we just did. And state the range and domain of each of those functions, again, using the fact of the range and domain you know from sech and coth. Okay, so pause there, have a go at those yourself. Okay, so let's see how far you got through these then. So y equals arsech x. So the first thing I did is rearranged it. And then once I've rearranged it, I can write it in this form. So I've done that. There we go. I've multiplied by e to the y plus e to the minus y. I've expanded it and multiplied by e to the y. So I get 2e to the y, x e to the y squared, x e to the minus y times e to the y just gets x. I've wrote it as a quadratic equation, and I've used the quadratic equation formula. And there we go, got this. I noticed that the 4's can come out, so I can definitely bring out the 4's, and that would be a square root of 2. So therefore I get the 1. But this time, unlike last time, then it is a bit more restricted. Because I've got a minus sign in here, 1 minus x squared, this means that this can't be anything bigger than 1. Because at the moment this is 2, for example. 2 squared is 4. 1 minus 4 is minus 3. You can't square root a negative when you're only looking at real solutions. So therefore, I have restricted to minus 1 and 1 in this case. Okay, what difference does it make to actually working out the equation? Nothing yet, so the 2 goes there. But also, just to be aware that 1 plus a square root is always going to be positive. Always going to be positive. So therefore, because the e to the y has to be positive. Okay, because e to the y can't be negative. So there's no point in having a minus sign just there. That's why we're only looking at the positive solution. All right, again, that didn't happen in the previous one, but it does happen in sech. So you've got to be aware of what the solutions work for. Now, because it only works for x is greater than 0, okay, because this one would meant it's negative, just there, and because, in this case just here, this is restricting you to less than 1, then this only works between 0 and less than or equal to 1. They're the only solution it works for. Okay, right, so the logarithmic form of arsech, let's have a look at what it works for. The domain of sech is not 1 to 1, so we do have to limit its range and domain. So the domain is anything bigger than 0, just there. Its range is anything between 0 and 1. It's quite nice to see that same answer coming up off the graph and from our discussions previously with what's the sort of limiting factor of the square root and the exponential. So therefore the range is anything between 1 and 0. Right, what about the arch sign then? Well, the arsech graph swaps these places. So this range becomes this domain, like we just sort of formed a minute ago. It had to be greater than 0 and because it couldn't be 0 because 0 can't go underneath it, and it can't be negative, and it has to be less than 1 because of this part just here. But also, the domain of being greater than 0 meant that the range can be greater than or equal to 0 as well. Okay, what about the coth graph then? How far did you get with the coth graph? And again, pause if you wanted to have another go yourself, if you didn't quite finish it. And let's see the difference with this. So arcoth, same idea, rearrange it to get coth, because now I can use the formula. The formula goes in there. Notice it was e to the y's equals x. I still multiply it across, and I've expanded it straight away this time. And I still multiply it by e to the y. So what's going to happen is that's going to go to e to the y squared. This is going to cancel, make plus 1. This is going to go to e to the y squared, and this is going to cancel just to make minus x. So there we go. Not quite the same sort of quadratic as the previous ones, but I can rearrange it. What's quite nice about this one, although it's not a quadratic like the previous ones, it's an easier quadratic to work with. E to the 2y equals x plus 1 over x minus 1. And there we go. Remembering that exponential function is positive, so I am restricted by the sorts of numbers I can put in because I only want positive numbers. So in this case, I do need to consider that. So first things first, I can get rid of the e by putting ln, and now I can put in the half. So therefore, it's sorted. As the negative numbers in the logarithmic function are undefined, so they are, you can't have negative numbers for the same reason as you can't have that as negative. Think about what the x values have to be for that to work. Okay, so hopefully you've had to think about it. The x has to be less than -1. Okay, because if x is in between, let's say x is 0, for example, 1 plus 0 is 1, 0 minus 1 is going to be negative, so therefore the ln function won't work, or the exponential function won't work, because this can't be negative. What about less than -1? Well, that would be bad, because this negative, let's say it's -1 here, -1 minus 1 is going to be -2, but the top part will be 0. That bit's okay. That would be okay, it's not negative, but remember the ln function can't equal 0, or an exponential function can't equal 0. So 1 doesn't work, but less than 1. So let's go for -2. -2 minus 1 is -3. -2 plus 1, sorry, 1 minus 2 is going to be -1 on the top, but that's okay, because they're both negatives, they cancel each other out and make it a positive. Works fine. Opposite way around as well. If I had something like the number 2, 1 plus 2 is 3, 2 minus 1 is also positive, it's +1, so therefore that works. Just numbers in between don't. Okay, so what does that mean then? Well, if I've got the graph, the function of this, I know the domain was anything other than 0. I remember the range of that graph, if you still got it in front of you, was anything greater than 1, anything less than -1, which we just showed. And now the range and domain is going to be the opposite way around. So the range here becomes the domain here, and the domain there will become the range there. Okay? Right, so what I'd like you to do is have a go at completing the exercise on 8B on page 185.